Hello viewers, how are you? Welcome to my channel TG Chemistry. I'm back with the set 2 of basic organic chemistry. As I said in my earlier videos that I'll be sharing second set of multiple choice questions on basic organic chemistry, and I'm here. So these are very important for the students of BTech chemistry and also for the exams like NEET, GATE, NET, and also for the chemistry students who are studying undergrad and postgrad chemistry. So let's see what we have today. The first question is, which among the following does not exhibit geometrical isomerism? Options are 1-hexene, 2-hexene, 3-hexene, and 4-hexene. Now the right answer for this one is 1-hexene. Next question is, which among the following defines mesoforms of isomers? So we know that mesoisomers, the mesoforms of stereoisomers, and the options are A, the molecules of the mesoisomers are chiral. Option B, mesoform is optically inactive due to external compensation. Option C, it can be separated into optically active enantiometric pairs. And option D, it is a single compound. So as the mesoforms are not optically active isomers, so these are basically single compound. So that is option D should be the right answer of this question. Next one is, the simplest member of organic compounds is. So we know that organic compounds are made up of carbon, hydrogen initially, and they can have the heteroatoms in addition to that. So what is the simplest example for that one? So with the options given over here, you will understand that option A, methane, is the correct answer. Name the process associated with acylation of benzene. Now we know the acylation of benzene involves Friedel-Crafts reactions. It is alkylation and acylation, both possible by means of Friedel-Crafts reaction of benzene. So among the four options, option C should be the right answer for this question. Fifth one is, a fat on hydrolysis would yield. That means if you hydrolyze a fat, what at the end product, what you are expecting. Options are ethanol and soap. Option B, glycerol and soap. Option C, ethanol and glycerol. And option D, only soap. Now the right answer is option B, glycerol and soap. Next question is, a nucleotide is formed of which of the following units? We know that the DNA and RNA, those are made up of the bases nucleotide and nucleosides. So the nucleotides are here in the question. So this is basically a nucleotide base and sugar and phosphate. And the nucleotide base is made up of nitrogen atoms. So this is the option A should be the right answer, that nucleotide is made up of nitrogen base, sugar, and phosphate. What amino acid is coded by the triplet of bases UGC? Very interesting one. And among the options given here, option A, tyrosine, option B, phenylalanine, option C, serine, and option D, cysteine. Now among these four, option D should be the right answer, cysteine. Which monomers are required for the formation of bakelite via a typical step growth polymerization? Now we know that bakelite formation or bakelite is a phenol formaldehyde resin. So this will be formed or prepared by a step growth polymerization process using phenol and formaldehyde. So option A is the right answer here. Next is, which of the following is not a disaccharide? Be careful, which is not a disaccharide. The options are sucrose, lactose, amylose, and maltose. Now the right answer is amylose. What type of macromolecule carries out catalysis in biological systems? Options are carbohydrates called starch, proteins called enzyme, nucleic acid called DNA, and lipids called steroids. Now the right answer is proteins called enzymes. Next one is, pyridine undergoes nucleophilic substitution reaction with phenyl lithium at 100 degrees centigrade to give which of the following? Now what happens when pyridine reacts with phenyl lithium? The correct answer should be 2-phenyl pyridine, and you see this is the structure of 2-phenyl pyridine and the fate of pyridine upon reaction with phenyl lithium at 100 degrees centigrade. Which of the following is true for any S enantiomer? We know for the optically active compound, the nomenclatures in my earlier video, if you go with the organic stereochemistry, I have discussed elaborately the tricks, also how to assign the chiral carbons in R and S forms. So this is, if you have gone through, you may know that answer easily. So which of the following is true for the S enantiomer? The options are: it rotates plane polarized light to the right. Option B, it rotates plane polarized light to the left. Option C, it is a racemic form. And the last option is, it is the mirror image of the corresponding R enantiomer. Now, you know by definition enantiomers are stereoisomers which are mirror images to each other. However, they should be non-superimposable to each other. So here option D is the right answer, that it is the mirror image of the corresponding R enantiomer. Next question is, what does a polarimeter measure? Options are: polarity of a substance, angle of rotation of an optically active compound, concentration of the substance, and pH of the substance. Now among these four, polarimeter is usually used for the, or in fact used for the for measuring the angle of rotation of an optically active compound. That means option B is the right answer here. Now a short numerical problem regarding this polarimeter or optical rotation. A solution of 0.1 gram per milliliter of with concentration of a pure R enantiomer in a 1 decimeter polarimeter rotates the plane polarized light by plus 4.8 degree. The question is, what is the rotation observed on this solution in a 2 decimeter polarimeter? So if the length is 2 decimeter, what should be the rotation measured? Now the working formula is the specific optical rotation equal to alpha by CL. So from there, if you calculate, the answer should be plus 9.6. So this is the working formula to calculate the right answer. Next question is, which of the following molecules exists as pair of enantiomers? The right answer is 2-cyclohexene 1-ol, that compound. Now with the four options here, option B should be the right answer. Next is, which type of precursor is used as reactant in intramolecular Claisen condensation? So in this part, I will be talking about little bit regarding the Claisen condensation part. So the first question is with that thing, and we know that for Claisen condensation reaction, it needs a molecule which have 2 ester terminals. So option B is the right answer, that one molecule with 2 ester ends will be the starting precursor for the intramolecular Claisen condensation. Next is, what is the other name of the intramolecular Claisen condensation? So this is a little bit tricky. Sometimes you are given with another name of reaction or condensation reaction, and you know the intramolecular Claisen condensation, but you don't know that name. So that makes sometimes a little mess. So here this question is put in that sense. So the options are Parkin condensation, option B Dykman condensation, option C Stobbe condensation, and option D Novenagel condensation. The right answer is option B Dykman condensation. Next is, which ester will not give a good yield of Claisen condensation product with sodium ethoxide in ethanol? Now all the four options are esters eventually, and option A should be the right answer here, which will not give a good yield in the Claisen condensation reaction. Which of the following is a product formed in Claisen condensation? Options are beta ketoester, beta ester, beta ketone, gamma diketone. Now the right answer is that the product should be beta ketoester as a product of Claisen condensation. So option A should be the right answer. Next comes, pyridine undergoes nucleophilic substitution with excess sodamide at 100 degrees centigrade to give which of the following? Now this is very important to understand that in the question is mentioned that excess sodamide will be used for the substitution reaction on pyridine. Now that will lead up to 2,6-diaminopyridine as the major product. Next, a little bit harder in that sense, that predict the product of the reaction where pent 2-ine upon reaction with potassium permanganate in presence of a base, hydroxide base, will yield the product. What should be the product? The options are pent 2,3-dione, option B pent 2-one, option C hex 2,3-dione, and option D ethyl acetoacetate. The correct answer should be option A pent 2,3-dione. The reagent for Swan oxidation. Swan oxidation is a very important tool for oxidation reaction, and what are the reagent that is being used in the Swan oxidation reactions? Options are A H2CrO4 chromic acid, H2O2 hydrogen peroxide, KMnO4 and base combination, and option D DMSO and triethylamine. Now the right answer is option D DMSO and triethylamine. Again, we need to predict the product when butane is reacted with Lindlar's catalyst. Now we know that Lindlar's catalyst is very specific reducing agent to reduce the alkyne to alkene, and it produces the cis isomer. So this is very important in that sense, that if you want to have the cis olefin or alkene from an alkyne, you need to use the Lindlar's catalyst. So the option A should be the right answer, that the product should be cis 2-butene. Moving from the topic in a different way, so going into the spectroscopy part, the next question is IR spectrum is a plot of, that means in IR spectra what generally we plot, that we get the graph over there. So options are percentage transmission transmittance versus time, option B peak area versus time, option C percentage transmittance versus wave number, option D peak area versus time. Now the right answer is option C percentage transmittance versus wave number. Still in the spectroscopic part, now if we are asked to calculate the lambda max of the following diene, you can see this is the unsaturated alpha beta unsaturated ketone system, the carbonyl ketone system. Now what should be the lambda max for this molecule? Options are 234 nanometer, 279 nanometer, 241 nanometer, and 273 nanometer. Now the base value of 214, and in addition to that one, it has the alpha and gamma alkyl chains, and also then external double bonds. So combining all these things, the right answer should be 279 nanometer. Next one is the IR band for C triple bond N, that is cyano or nitrile group, is observed in the range of, options are 2260 to 2200 centimeter inverse, option B 3000 to 2800 centimeter inverse, option C 3400 to 3300 centimeter inverse, and option D 1750 to 1650 centimeter inverse. Now typically for C triple bond N, the IR spectrum band is arrived at option A 2260 to 2200 centimeter inverse. So this is option A is the right answer. Next is, which of the following alkyl halides would undergo SN2 reaction most rapidly? Now you see all the four options are alkyl halides, and all are ethyl halides in fact. So the driving factor or the determining factor should be in SN2 reactions that how easily the leaving group departs. So in that sense, the Ci bond should be the weakest one, and the I- will depart easily. That's why the answer should be option D, ethyl iodide will be more reactive. Next is, the paper chromatography is an example of, options are partition chromatography, option B thin layer chromatography, option C column chromatography, option D, adsorption chromatography. Now we know that paper chromatography is an example of partition chromatography. So option A is the right answer. Next is, a tertiary butyl carbocation is more stable than a secondary butyl carbocation of which of the following? Options are minus R effect of methyl group, option B plus R effect of methyl group, option C hyperconjugation effect, option D minus I effect of methyl group. Now with the options we understand that that hyperconjugation is going to be the right answer. So option C is the right answer of this question. Next is, identify the one which does not come under the organic addition reaction. So which kind of a reaction is not an addition reaction in the organic chemistry? Options are A, hydration, B, dehydration, C, halogenation, and D, hydrohalogenation. Now option B is dehydration. That means some water molecule is leaving the substrate and is going out. So this is not addition. So this is in terms of elimination of a molecule. So this is not under the organic addition reaction. So option B should be the right answer here. Next is, what will be the reactivity of chlorobenzene in an electrophilic substitution reaction with benzene? Options are, chlorobenzene will react in same rate as benzene, it will react very slowly than benzene, it will react faster than benzene, or it does not react at all. Now the right answer is option B, it will react very slowly than benzene. Next is, most commonly used internal standard for recording nuclear magnetic resonance, that is NMR spectra, is, options are trimethyl silyl chloride, tetramethyl silane, trimethyl silyl iodide, and chloroform. Then the right answer is option B, tetramethyl silane, as the internal standard for measuring or recording NMR spectra. Next is, in general, melting point of fat is space and melting point of oil is space. So we know that the melting point of fat is higher. So from the options we see that there has to be something between A and C. Now definitely the melting point of oil should be the lower one. So option A is the right answer, that in general the melting point of fat is higher and melting point of oil is lower. Next question is, CCl4 tetrachloromethane acts as an electrophile due to, options are minus I effect of Cl atoms, option B incomplete octet, option C plus I effect of Cl atoms, or option D vacant d orbital. Now the right answer is option A, minus I effect of chlorine atoms. The relative overlap of hybrid orbitals increases in the order. Now we know that in sp hybrid orbital it is the 50% of s orbital and 50% of p orbital. So the overlap is maximum in sp orbital. So option B should be the right answer, where it is in the order of decreasing from sp to p orbital. So option B is the right answer for this question. Which of the following will give effective reduction of 3-hexane to trans 3-hexene? If you remember, we have already learned that from alkyne or triple bond, when we are having the cis olefin, we use Lindlar's catalyst. Now here the question is the other one, that how from 3-hexane we can obtain the trans 3-hexene, that is the trans isomer. Options are A, H2 Lindlar's catalyst, B, Dibal, C, LaH, that is lithium aluminum hydride, and option D, sodium liquid ammonia. Now the option D should be the right answer for this question. How acetophenone can be converted to phenol by reaction? So acetophenone having the structure C6H5COCH3, and from there you need to prepare C6H5OH. So here the right answer should be option D, that metachloroperbenzoic acid followed by the base catalyzed hydrolysis. If we impart this reaction condition on acetophenone, it will end up of generated phenol. So option D is the right answer. Next question is, which is the mildest reducing agent which reduces only carbonyl group in presence of nitro, carboxyl, double bond and ester groups? Now, sodium borohydride is the mildest reducing agent which will perform the act accordingly. So option A should be the right answer. Next is, which of the following groups has the highest priority according to the CIP, that is Kahn-Ingold Prelog rule or sequence rules? Options are CH2Cl, CH2OH, CHO and CH3. The right answer is option A, CH2Cl. 40th question is, which is the correct combination of reagent which can carry out the following conversion? You can see this is an alpha beta unsaturated cyclic ketone, and you have a methylation at the beta position with respect to the carbonyl group. And so what should be the combination of the reagents that should be used to effectively perform the transformation? Now, among the given options here, option B should be the right answer, that is methyl lithium and then protonation followed by pyridinium chlorochromate oxidation in presence of heat will lead eventually to this product from alpha beta unsaturated cyclic ketone, cyclohexanone. Next one is, the drug papaverine has a backbone of. Now we know that papaverine is a drug which is having isoquinoline backbone, so eventually option B is the right answer in this case. Next one is, in which state of matter mass spectroscopy is being performed? Now we know that mass spectroscopy is done in the gaseous state, so the right option should be option B. This is the right answer. Next is, the separation of ions in mass spectrometer takes place on the basis of which of the following? Options are mass to charge ratio, option B mass, option C charge, option D molecular weight. Now the right answer is option A, mass to charge ratio. Next, which of the following molecules will not show infrared spectrum? That means which of the following molecules is IR inactive? Options are H2 hydrogen molecule, option B HCl, option C methane, option D water molecule. Now the right answer should be option A, hydrogen molecule, which will be IR inactive. Next is, phosphorescence spectrum of the excited species is due to which transition? That means when the phosphorescence occur, which kind of transition lead to the phenomena phosphorescence? Options are singlet to triplet transitions, option B triplet to singlet transitions, option C vibration modes, option D electron spin transitions. Now the phosphorescence is associated with the transition of electrons from triplet to singlet state, so that option B should be the right answer for this question. Next is, what type of reaction takes place upon treatment of a ketone with hydrogen cyanide to form a cyanohydrine? Options are electrophilic addition, option B electrophilic substitution, and option C nucleophilic substitution, option D nucleophilic addition. The right answer is nucleophilic addition. Which of the following is the definition of chirality? Options are a molecule with a mirror image, option B the non-superimposability of an object on its mirror image, option C a molecule without a mirror image, and option D the superimposability of an object on its mirror image. So we know that for a molecule to be chiral, its mirror image has to be non-superimposable with the original isomer. So option B is the right answer for this question. Next is, the reducing agent used in Stephan reduction is. So we know that in Stephan reduction, stannous chloride and hydrochloric acid is the combination for the reducing agent. So option C is the right answer. Which of the following can make difference in optical isomers? So among the options, polarized light, heat, temperature and pressure, we understand that polarized light should be the criteria that can affect the optical isomers. So option A is the right answer. The last question of this set is, which of the following methods is best suited for the separation of a mixture containing naphthalene and benzoic acid? So if we have a mixture of naphthalene and benzoic acid, what should be the best method to separate them? Options are crystallization, option B sublimation, option C chromatography, and option D distillation. So the right answer should be option B sublimation. So thank you guys for watching my channel TG Chemistry, and keep watching my channel to have more videos on this kind organic stereochemistry or organic chemistry, or the competitive exams covering the chemistry papers for from class 11 to all kind of exams up to the postgraduate, and also for NET and GATE exams. So thank you very much.